Andy Pavlo, welcome to Software Engineering Daily.
Happy to be here. Thanks for having me.
Awesome. Well, I'm super excited to have you here because you're someone I've sort of followed and read about in the database community. You've done a lot of work. I think it's interesting because you're in sort of two worlds, right? So you're in the academic world. You're associate professor with indefinite tenure in the computer science department at Carnegie Mellon, doing all this awesome database work there. But you're also in the private industry world. You're CEO, co-founder of Autotune, and I want to talk about both those today. But maybe just anything else I missed there or cool stuff you're working on.
That is accurate. So the indefinite tenure is it basically means I have tenure as of this year at CMU, which is good. It means I still can get fired. It just I have tenure. No, yeah. So I'm happy to thank you for inviting me. I'm happy to be here. Yeah, my background is in database systems, and part of the reason why we've been doing we have with the startup Autotune as well as maintaining my foot in the university is because I like to think that there's a lot of interesting things happening in the real world, and I'm using sort of we pushed things out that was research into a startup, and then I'm sort of also getting feedback about other future problems we may want to investigate, back at the university. So it's been a symbiotic relationship, and it's been pretty fun.
Awesome. And I assume, congrats on the tenure. And
Yes.
I assume that means that you can now advocate for NoSQL and blockchain and all these other things that you've been sort of holding back for all these years, right?
Not in my life, actually. No.
Okay, cool.
Yeah.
Well, I want to start with Autotune. I think it's super interesting. So Autotune, I would say is like sort of self-driving database in some way or automated optimization, things like that. Maybe you just tell me what is Autotune? What is it doing?
So Autotune is a automatic database tuning as a service. We can talk about the self-driving database stuff. That's sort of a separate research direction. But the original idea was that we were looking to use machine learning to automatically to configure and optimize database systems. And this is work was done back at the university with my PhD student, who is now a co-founder with me as well, Dana Van Aken. And her research was really about how to use machine learning to automatically tune the runtime knobs of database systems. So you can think of like a database system like Postgres, MySQL, Oracle, pick your favorite one. For the most part, they're essentially like general purpose software, but they have these knobs that you can tweak and change for how the application expects to use the database system. And so you can tweak them certain ways to make them faster for certain type of queries or certain type of workloads versus others. So the metaphor I like to use sometimes is think of this as like the database is like a generic car frame. I can put big wheels on it and make it a pickup truck and haul things, or I can put a fast engine in it and make it a race car, right? But the frame is essentially always the same. So that's what Autotune is trying to do, is trying to tune these knobs for exactly how, for how the application wants to use the database system. And the reason why this is hard and why we think we need machine learning and artificial intelligence techniques is because over the last 2 decades, if not longer, these very popular open source database systems have been adding lots and lots of more of these knobs where it's beyond the sort of capabilities of a human to figure out how to tune them and reason about them. So I just offhand, I'll say for Postgres, since like the beginning of 2000, they've gone from maybe less than 100 knobs to over about 300, 400 knobs. And MySQL's went from less than 100 to about over 500 now. Now, not all these knobs will affect performance in the ways that Autotune can actually tune them, but there's still a lot there. And what we have found is that with the rise of DevOps and the somewhat relegation of the less prevalence of DBAs at a lot of tech companies or any company, there's not people that know deeply what's going on inside a database system. So Autotune sort of seeks to automate that, take that burden off of them for them.
Truly, absolutely. So in terms of the things it's actually tuning or the things that affect database performance, I think instance size, I think indexes, I think data model, and then also the configuration. So it's mostly configuration like buffer size, file limit. I assume things that are way more important than that, but like those are the things that it's sort of going after.
So the current version of Autotune, the original version of Autotune at the university, and then what we end up commercializing and build as a startup, it would just touch knobs. Because again, there's enough of them that and these things matter from our experience of what we've seen in the real world. When you start getting into other database problems like indexes, query tuning, instance size that usually falls under capacity planning or provisioning, those are where we're going next with Autotune. So that the newer version that we're going to announce and release later this year. What we basically have found is that the knob tuning makes a huge difference, but getting people to use Autotune correctly and safely has been sort of a challenge for us. And when people do use it correctly, it's fantastic. But there's oftentimes other things that they have wrong with their database. No matter knob tuning can fix that. Like if you don't have any indexes on your tables, then who cares that your buffer pool is tuned exactly because you're just doing sequential scans. So that's where we're going next with Autotune. The other challenge we faced is that it's hard to in real world applications to be able to convey back to the user like how much Autotune made things better for them if you just do knob tuning. So again, when we did the early rollouts or the trials at the university and the startup, we talked to customers that could take snapshots of the database, a clone and a workload trace, and run the spare hardware, do all the tuning there, and then put it in production, and then get all the benefits there. A lot of people can't seem to do that, either for technical reasons or just time reasons. And no amount of machine learning can make that better, at least from where we stand at Autotune. Like, since we're not the service provider, we're not running RDS, we're not running the database for them. We're on the outside. We can only do so much. So then the newer version of Autotune that we're building out is starting to look at some of the other things that you mentioned.
Awesome. And then, so walk me through the process. You sort of mentioned a little bit with workload tracing and snapshots. What's the process if I come to you, want to use Autotune? Like, is it going against my production database, or am I spinning up a clone and sort of doing that, or what am I doing there?
So the way it works now is that you sign up for a free account, and you would give us the right IAM permissions on AWS. So Autotune currently supports MySQL and Postgres, both the regular RDS and Aurora versions, but only running on Amazon. So you would initially give us permissions to, at the sort of the AWS level, see the databases, see the RDS instances, and we can collect some basic information from CloudWatch and Performance Insights. Like, this is like benign information, like CPU utilization, some of the internal metrics the data system exposes. Like, we're not looking at any user data, any queries at that point. And so for that initial sort of permissions, we can then calculate some things, identify. We basically run health checks to show you like, hey, these things look wrong. Here's how maybe some things can fix them, or hey, these other things don't look good either. And then the solution might be then to download our agent, like a Docker file that you run in your network that then connects to the database. You give it additional permissions to start looking at additional metrics and telemetry the database starts collecting, and that sends us back to our secure service. And then we can start providing other recommendations and identify other issues. And then you can then also enable the sort of ML-based tuning to get sort of the full benefit of this. So from our perspective, we recommend that people don't do the ML tuning on the production database. Most people listen to us. For some reason, Brazilians do not. I don't know why. We're like 4 out of 4 for Brazilian customers we talk to. They're like, hey, this is machine learning. You don't want to run this production, like not right away. Like, oh, we don't care. It's really bizarre. It's like driving without a seatbelt. So now I would say we put a bunch of guardrails in place to make sure that people don't shoot themselves in the foot. But it's, if it's your production database, you obviously want to be very cautious about this. So the next version of Autotune we're working on now is we can do sort of more lightweight ML things about, indexes and other stuff that you can get some of this benefit in production more immediately, but then you can then still switch on what I'll call the Autotune Classic and get the full-fledged machine learning capabilities. And then you have the ability to, identify, is this a production database versus a dev staging database, and be more aggressive maybe in the staging one, and then know how to link that and apply the changes to the production one automatically. So that's where we're going in the next year, to have a clear identification of what's dev versus production. But for now, it's all, from our perspective, it looks the same.
Yeah. And so if it's running automatically on prod, it's actually like, is it changing those configuration values for it if you sort of set it ahead, or could it like generate a report for you and say, hey, recommendation is to change this buffer pool, but it's up to you. Yeah.
So that turned out to be the number one request we had when we came out of stealth. We said, hey, no, we're no longer a research project. We're now a startup. People asked us like, this is fantastic. I want this, but I want to be able to approve any changes before Autotune does anything. And so we have this human in the loop feature where the machine learning algorithm will run, and then it produces a report and says, these are the changes we think we should make. And then a human has to come and say, I want that. We don't have the ability just yet to say, give good explanations why Autotune makes these changes. Again, it sounds like I'm like sort of talking about what's the future, what's coming, but we're actively working this now. We want to be able to say things like, all right, here's the recommended change we want to make. Click here to let Autotune make it or not. And oh, by the way, 95% of Postgres users that when they applied similar changes got this benefit. That would give us sort of the additional peace of mind we think we know that customers are asking us for. So that's where we're going next.
Yeah, cool. And what are there certain types of workloads or customers that you're seeing Autotune like really resonate with? Like at first I was thinking, hey, enormous workloads where they have these huge scaling problems, but then I'm like, hey, maybe they also have a team of DBAs that can handle this. Maybe it's like a smaller team that doesn't have a DBA. So I mean, like, what are you seeing? People
honestly at this early stage, it's everybody.
Yeah.
We've talked to large companies that have in-house DBAs, but oftentimes what they tell us is either the scale is too large and they want machine learning, they want something like Autotune to take off some amount of burden in their daily job, or they have inherited or acquired some other company that maybe is running Postgres, whereas they're all Oracle DBAs or DB2 DBAs, and they don't know anything about Postgres and they can learn a little bit, but they want Autotune to help them get them there. So there's big companies like that. There's certainly large tech companies that don't have in-house DBAs, and it's all DevOps. And then there's the mid-range shops where they don't have a DBA. They're considering getting one, but then they realize how expensive that is and how hard they are to find the good ones. And they're trying Autotune out as a way to maybe kick the can down further down the road and see how much they can still automate through us before they have to hire somebody else. And then certainly there's the smaller stage startups and companies where, again, they don't have a DBA. We don't actually recommend they get a DBA because if you're paying for an employee just to maintain your database rather than building your application, that's not really good for an early stage startup. So Autotune is useful for them to help them, as the application grows, their database can grow with them.
Yeah. Awesome. I think that's so cool to see. And especially that first one you're talking about, like where they have some DBAs, but if you could just reduce the space they have to search, or like sort of like we're seeing in like chess, right? Where like computer plus really good chess player is better than computer alone or person alone. It's like they can, really supercharge that sort of stuff.
But sometimes we see they have like tens of thousands of databases.
Yeah.
So we've seen like MySQL hosting companies where, they have 10,000 different little WordPress apps or whatever, and no human can go tune every single one because it's just, it can't do it at that scale.
Yeah.
Now, Autotune can't do everything, right? It's machine learning has its limitations. Anything that requires a human to make a value judgment, right? Autotune can't do that because a human has to decide whether it's the right thing. Yeah. And this goes back to what I was saying before for the two, where we have to make sure we have the right guardrails in place and make sure bad things don't happen, because the machine learning algorithms figured out that not writing things to disk make things go faster, which is true, but like then you crash and lose data, and that's an external cost the algorithms can't reason about. So we have a bunch of those things in place, which actually takes the most amount of time, more than the machine learning itself, to make sure we do things safely.
Very cool. One thing that I think that's interesting on your site right now, you have this Autotune Relational Riverside Rumble. So human versus otter. Tell me a little bit about that.
So, I mean, this is, people ask us oftentimes, like, how good is it, right? And I'm like, oh, that's a good question. I don't know how good it is. We have an academic paper that came out in 2021, where we deployed Autotune at a bank in France, and we did compare against their in-house DBA, and sometimes we beat them, sometimes they beat us. But that was on Oracle. We want to know how can we do for like Postgres and MySQL. So the Relational Riverside Rumble is a contest we're having this year, which we're going to hold at re:Invent at Amazon's big conference in the end of November, where we want to pit a live human DBA that's not affiliated with Autotune against Autotune and see what happens. And if the human can beat us, they'll get $10,000. If they lose, we'll still give them some portion of money, and then we'll donate the rest to the Otter Wildlife Fund, which is based out of Britain. But the key thing about this is we want to do this comparison on a real database. Because certainly in academia, we would always compare against TPCC and the other standard benchmarks everyone uses. All the other academic papers do the same thing. We have just found in the real world, it's the workloads are so much more varied than what's available in academia or synthetic workloads. So we're still working on this now, and making the arrangements. But we're going to do this comparison on a real database from a real customer and pit the human against Autotune. And then we'll live stream it that week during re:Event. And then, it would be available on Twitch and YouTube.
Yep. Awesome. I'm looking forward to seeing that for sure.
And if we win, fantastic, right? If we lose, that's good too, because it will just be like Gary Kasparov and come back the next year and do it again.
Exactly. And you learn something. It kind of reminds me like the Netflix prize too, when they like
Yes.
had that competition and it ended up improving their recommendation. So yeah, that's cool stuff. I want to talk a little bit I guess I don't know, like what's the reception like in the database community? I imagine there are camps where like, hey, it can't be automated, like they're too varied, or is it like pretty much like, hey, this is where it's going and we should be moving forward on this? Like what's it look like?
I mean, the real question is like, what do DBAs think about this, right?
Yeah.
So the DevOps people, developers, everybody else, everyone's on board with this, right? And I think partly because they maybe don't know the full complexity of database systems. And also like they know, or maybe they face the challenges and they scramble to try to solve them before, and they just know they don't want to do it again. So everyone who's not a DBA has been on board with this as well. The DBAs have actually also been very enthusiastic and supportive of this as well. So I mentioned that competition we did, or that the research study we did with the French bank. That was at the behest of their DBA teams, right? Because they wanted to see how well could Autotune do at their scale and their environment, because they were certainly struggling with it. And if you just think about it, the original idea of doing automated knob tuning, that's not something DBAs actually spend a lot of time with anyway, right? Yeah. Because maybe they had 5 or 6 knobs that they always tuned, and that got them, maybe 60%, 70% of the way there. But it's obviously squeaking out that last bit of performance is super hard. And they had so many other things to do. They were not doing knob tuning. So for classic Autotune, again, the knob tuning, everyone has been super supportive of this. And then where we're going next, with query tuning, index tuning, resource provisioning, and sort of cloud configuration stuff, basically modernization of running databases in the cloud. They also seem to be very supportive of this as well, partly because they have, again, so many other things to do. And if Autotune can just take care of these things for them, they can spend time, doing the higher level things that, again, we can't easily automate, like application design, schema design, figuring out what the right queries to write for different reports and things like that, backup and recovery, like all those mechanisms. Yeah. Autotune is just making it easier to them do the more fulfilling things in their day-to-day job.
Yeah.
So when we pitch it sort of that way, everyone also seems to be supportive as well.
Nice. Okay. And then a few last business specifics about Autotune. Like, have y'all raised funding? How many employees do you have? What's it sort of look like as a company?
So we've just raised our Series A in April 2022 with Intel Capital, Raise Capital, and Excel. Prior to that, we did a small sort of seed round / angel funds with database friends like the founders of Databricks, Snowflake, MemSQL, like Cockroach, but again, a bunch of database people. Yeah. And this guy, actually, Amarjeet Gill, who's been very, very supportive of us. When we raised the first initial funds, I basically went and hired all my best former students from Carnegie Mellon. Yeah. And we set out to rewrite the software and build a commercial version of the academic project. So we did that. And then we sort of launched self-service version Autotune. And as I was saying, what we learned from releasing the software was the knob tuning makes a huge difference, but getting people to use it fully has been I won't say a struggle, but it's been non-trivial. It's been harder than I anticipated. And so with the Series A, the new funding, we're building the new version of Autotune that starts to look at all these other things that people care about in databases. And so that's we're hoping to announce that the same week we have the contest will be sort of the announcement of the new version of Autotune. So we've raised total, I think, about $14.5 million. And we're currently, I think, 26 people.
Wow.
We've started hiring people outside of my sort of the CMU network, right? All my students do databases, but you need people to do front end and marketing and product design. So we've been very fortunate to hire some fantastic people that weren't my students to help us build the product. So we're super excited.
Yeah, cool. I want to move into the academia side here, but when you mentioned that hiring all your former students, what are most of these former students that are really getting deep into database stuff? What are they doing? Are they doing more were you hiring them out of academia? Do they go work for big tech companies that are optimizing, Google's MySQL, or like what sort of things are they doing?
So you can sort of break it up between like sort of undergrads, master students, and PhD students. I've since I started at CMU in 2013. Most of my PhD students have gone in academia. My first student is now a professor at Georgia Tech. My latest PhD student is now starting a professor at University of Michigan. Dana, I mentioned, she's at Autotune, and actually my other PhD student is he's at Databricks. So for PhD students, it's been a mix, but more of them go to academia. For undergrads, the very best go to do PhDs in databases, and it's been mostly split between. I keep some of them at CMU, which is somewhat selfish, but I mean, if they want to stay, fantastic. But then a large number of them end up going to MIT. For master students, most of them go to industry, and most of them, if they hang out in our group, they end up going to database companies to build, or either startups to build database systems, or Google, Amazon, and larger companies specifically work on databases. So I think most of them. I don't have exact tally. In the last 5 years, a lot of them ended up at like Snowflake and Databricks. But pretty much, you name a database startup company, I might have a student there.
Yep, awesome. So let's go deeper on the academia stuff, because that's where I've sort of heard about you and learned a ton from your stuff. Mm-hmm. So maybe let's start with this. I don't know exactly how you call it, database tech talks or your seminar series or whatever it is. Maybe tell people, but there's just this enormous wealth of videos from super knowledgeable people talking about databases in association with your class. So maybe tell us a little bit about the work you're doing there.
So I run a seminar series every semester, the fall and spring semester, where on Mondays we invite people from industry to come talk about their database systems. And this originally started when I was in grad school. I was sort of co-teaching a class with my advisor at Brown University, and New England and Boston area had actually a lot of database startups. And as I consider it sort of my duty as a researcher, academic, to understand what's going on in industry. And so we'd invite them to come to the class and give a talk. And then when I graduated and started at Carnegie Mellon, I sort of just continued the same thing, but rather than doing it part of the class, we have this consortium at CMU called the Parallel Data Laboratory, where we can invite people from the outside to come give talks on Thursdays about database systems, because that's what I cared about. And the reason why I think this is super important, because databases are unlike other sort of areas in computer science and systems, where not only do you have to compete as an academic, you have to compete with other academics, other universities. You have to compete also with the large tech companies, the Googles, the Microsofts, and Amazons, because they're building database systems. Then there's all this other, VC money sloshing around, funding all these other database startups. So there's all these other people as well, right? I think this is very rare. Like, you think in operating systems, there's no, everyone uses Linux. Like, there may be some VC-backed OS startup, but I can't imagine. I don't know any, right? But in databases, there's so much. So to make sure that like my research is grounded in trying to solve real world problems, and I'm not just reinventing the wheel that somebody else at another company has solved, I make it an effort to try to understand what everybody's doing. And so we started inviting people to come give talks. And before the pandemic, we would invite them on campus and set up meetings with other researchers and students and take them out to lunch. It was a big production. So we maybe only invite maybe 5-6 people per semester. And then the pandemic hit, and I was like, all right, well, everything's on Zoom. I'll just invite everybody who I always wanted to invite, but I couldn't fly out. People in Europe, people in China, people in Australia. So like, that's been super fun. Just every Monday now, we have somebody else come give talks about databases, and I learned a lot from it. And so again, prior to the pandemic, I would try to have a theme at least about what the seminar series would be about. Like one semester, it was embedded databases, so like SQLite, RocksDB, WireTiger. Then we did time series databases. We did hardware accelerated databases, like database running off GPUs. But now, honestly, it's whatever Andy thinks is interesting. Yeah. And so it's a bit random. There isn't really a theme about it. But I would say that I try to maybe get people to talk about query optimizers, which is usually the black art, the most secret part of a database system. Sure. So we had some really good talks with them. But recently it's just been like, hey, this showed up in Hacker News. I want to learn more. We invite them.
Yep. Oh man, that's awesome. And I believe we're recording this in mid-September 2022. I believe that the seminar starts tomorrow. Is that the first
correct
one of it? Okay.
Yeah. So the first speaker tomorrow is actually Thomas Neumann, which you haven't talked to him. You should get him on this podcast. He is honestly probably the best database researcher in the world. And I don't say this word lightly. He's a genius. How does this? He's got 3 kids. He teaches 2 classes per semester. I think he's the department chair at TU Munich. And then like he was running or doing something for like the COVID vaccine distribution in Germany. Like he's doing all these things, but he still feels time to like program this database system 8 hours a day, right? Like he's got to be on cocaine, but I know he doesn't drink. He's amazing, and he's like the nicest person. Anyway, so he's giving a talk about his database system called Umbra, which is the second one he's been building since the last one they sold to Tableau in Salesforce called Hyper. Anyway, so like this is just, I think Thomas is a great person. And I think more people outside of academia need to know who he is. So that's why we invited him first.
Awesome. I'm gonna definitely look him up after this. And I'll put this in the show notes, but like absolutely check out this databases series because it's just amazing the like breadth and the depth that you can get from this stuff and like whatever sort of database, like you're saying, embedded time series, interesting stuff on MySQL, Postgres. There really is a lot of cool stuff. So we'll put some stuff in the show notes on there.
And what's been really good is we specifically asked not for them to bring marketing people.
Yeah.
Right. Or PMs. Like it's the engineers actually building the systems.
Yeah.
And we tell them, hey, like your podcast, hey, if you say something inappropriate, you can cut them out. And we tell them that, and sometimes they still dish the dirt about like, hey, there's a dark corner, like here's something stupid we did, but like here's something stupid we see their customers doing too. So that's been super, super awesome. Even though again, everything's public, it's on YouTube and Zoom, anybody can comment. You don't have to be affiliated with the university, and they still they're very open about what they talk about, what they talk about.
Awesome. I love it. Okay. So what I want to go to now is just like, you get to see all these people, you're in this database area of academia. Like, what are the interesting trends, patterns you're seeing? I have a few I want to ask about, like what's exciting to you right now that you think is really interesting?
So I think, again, for database systems, I think we're in, I haven't really articulated my thoughts yet entirely, but I think we're actually in the golden era of databases. Similar to like the golden era, movies or TV, where like there was just so many different choices that were like all very high quality. That's sort of where we're at now. And I don't know if that's a byproduct of VC money or open source software. I don't know I don't know what happened, but there's a lot of great choices now that are really, really good. Some are open source, some are cloud-based, right? But there's so many choices now. And for me, just thinking more long-term, because I can in academia, I don't foresee what's the next major thing coming on the horizon where, there'll be a bunch of people scrambling to build a new system. Like if you look at like Snowflake when it came out in 2013, like they were sort of the first cloud native vectorized data warehouse. Redshift came, soon after, but like, they were hacking on Excel. But by now in 2022, vectorization is super common. Query compilation is less common, but the research basically shows that you get roughly the same benefit overall for if you vectorize the query engine versus do code-gen query compilation. Some systems do both. Some systems choose one or the other. But the point I'm trying to make is like I don't foresee there's some major thing coming on the horizon, like new hardware, a major change where the database world is going to get flipped over upside down again, and everyone's scrambling to build something new. Intel killed Optane this summer in 2022. I actually thought that was going to be a big game changer, but there were some companies building Optane, persistent memory optimized systems, but that's not happening anymore. So I really don't know what it is.
Yep.
Potentially, I think it's going to be just the heterogeneous hardware, like the dominance of Xeons or the x86 architecture. I'm not saying it's GPUs, but like custom ASICs, things with ARM or RISC-V. I think the next decade the hardware is going to get pretty wild, and so there could be database systems that are built that are optimized for these different pieces or different hardware types. But a lot of the stuff that actually matters is up above, like the query optimizer, for example. Yep. Like who cares if your engine is super fast if you choose crappy query plans?
Yeah.
So I think where we're at now for this next decade is sort of commoditization of high performance data warehouse engines and transaction engines. And so what exactly is going to come out next? I don't know. And I honestly, I think it's the stuff up above. Not to push Autotune, but that's an example of the up above stuff. Like, who cares how fast your query engine is if you can't build the right indexes, so you can't tune things correctly. Yeah. And so that's what we're sort of focused on now.
Yeah, absolutely.
And so I think newer hardware could be a thing. I am excited to see how more of these sort of like the Rust or Zig, these sort of safe memory languages, how they're becoming more prominent in kind of systems building of those. But I don't think it's a game changer in terms of the architecture of the system is dramatically different.
Absolutely. You mentioned both like analytical and transactional ones, and we've seen a little bit of talk of like the whole HTAP, like hybrid transactional analytical. I think Snowflake had something at their latest conference talking about that. What are your thoughts on that? Are we going to see more hybrid type stuff, or are we still going to see more specialization into, at least those two worlds, analytical and transactional?
So full disclosure, I was a tech advisor for Splice Machine, which was pitching itself as HTAP engine. And then they went under, I think, last year. I think it'd be very hard for a newcomer to come along and say, and try to build an HTAP system from scratch. Because if you think about it at a company, the stakeholders or the people that care about the OTP are oftentimes different. The OTP data is oftentimes different than the data warehouse engines. So the OTP people, the people building the front applications, they want the best OTP engine you can possibly get. I'm not saying what that is, which is that in their minds, they want whatever that is. And then the same thing with the data warehouse people, they'd want, whether it's Snowflake or Redshift or Firebolt, whatever it is, they want the best OLAP engine. For someone to come along and say, I have something that can kind of do an okay job of both, that's a hard sell. And so I think the Splice Machine approach, where like, hey, let's build an all-in-one solution that comes out of the box as all-in-one solution. I think that's I don't foresee that happening. Yeah. Instead, I think it's going to be essentially what Snowflake is doing, where with Unistore, where you have a sort of best-in-class data warehouse or a best-in-class OTP engine, and then you add some capabilities that can do a little bit of what the other side can do. That's essentially how things are going to go forward. Yeah. So I think I think that whether that's called HTAP or whether that's just like, hey, we add now analytics for transaction engines. I don't see HTAP support I don't see that being sort of a key differentiator in the marketplace.
Yeah, I think it's so hard to really merge those worlds in a way that doesn't sort of degrade performance on each side. So yes. It's a tricky one. What about like more specialized use cases? I think you have SpiceD coming this year, who's like a specialized auth-ish database, sort of some of that's application-ish type stuff, but even like time series, graph search. Like, do you think we're going to go deeper and deeper into those more specialized use cases?
Yes. So SpiceDB was trying to solve the problem of specific authorization. So they talked last year. The one database we have been speaking this year that is another example of a specialized engine would be Tiger Beetle, where it is a high performance engine that only does ledgers. It only does accounting transactions. Mm-hmm. The API is very I think you can insert a new entry and delete an entry. Like it's very specific, limited what you can do. So specialized engines are always going to outperform sort of the general purpose ones. The question is whether the specialized engine is going to have such a significant difference in performance that can overcome the limitations of a general purpose one. So by general purpose, I would say like MySQL, Postgres, Mongo, Oracle. People think of a database system. Yeah. The challenge oftentimes is the benefit you're getting from a specialized engine, is that truly because the engine is different or the API is different? So an example of this would be like in a graph database. So if you're trying to do graph traversal, you can write this in application code in SQL without recursive queries, but you can do the graph traversal by writing a query, getting a result, then the application code does something, and then you run the next query. And so it's a lot of back and forth, and that's going to be slow. And so oftentimes in the graph databases, they have API calls, API commands, where you can do the graph traversal in a single query and then avoid that back and forth. And that's what they may claim is one of the reasons they're better than relational database for graph workloads. But like, you obviously can build a graph like veneer on top of a relational database and to do that traversal all on the server side without having to go back to the application and get almost all, if not the same or if not more benefit, right? So the specialized engines, I think I'd be hesitant to say we're going to build something from scratch, and that's why it's better versus like you just have a better API on top of Postgres. So you mentioned SpiceDB. I think they had plugins they could run off Cockroach. I think also Spanner, but they basically had a specialized API on top of a relational database. I think that's where things are going. And this goes back to the statement I was saying before, like what's different in the next decade. There's so many good databases out there. It's very hard to see what's, from my perspective, what's something you could build from scratch, an engine that you simply couldn't do in an existing relational database, or you couldn't take Postgres and put in extensions and foreign data wrappers the way Timescale did and do better for time series that way, right? So it's very hard to see what that actually is going to be at this point. Tiger Beetle, for example, would be one where like they're doing things. It's a very, very narrow application use case, right? It's just that ledger, and that's why they can build something that's super fast. And it just so happens that use case is super important for a lot of applications.
Yeah, there are people willing to pay for that, almost for that specialized type thing where other ones might not have that. You mentioned Spanner, Cockroach. We've seen other distributed SQL, Yugabyte, Vitesse, PlanetScale. Like, what do you think about the whole distributed SQL thing? Are we going to see a lot more of that going forward, or will just vanilla Postgres, vanilla MySQL get good enough for most people, and to where most won't need that?
So I have to admit, I was so surprised that what I call the distributed SQL systems, the Yugabytes, the Cockroaches, that they took off as much as they've done. And I say this as someone who was a early proponent of NewSQL. I worked in my research. My PhD research was on a system called HStore, which was commercialized with VoltDB. And I admit I was totally a proponent of like, hey, this is the right way to do transactions. I still do for some things, the way VoltDB does it. But there was issues of at least the case of VoltDB, that it wasn't like a drop-in replacement for Postgres or MySQL. Some of these newer systems are. And so the other challenge I also saw from the early NewSQL days was just how hard it was to supplant or to replace Oracle or other and enterprise transaction database systems. And the Cockroach guys and the Yugabyte guys seem to have sort of cracked that nut, at least certainly for greenfield applications. I don't know if I don't think if people are replacing Oracle for Cockroach or other things. I'm sure they are, but I imagine I suspect it's mostly new users using them. And so I think that part's different than what the NewSQL guys were able to do. And so do I see more distributed SQL systems coming along? Again, I think it's, I'm sure, yes, but like those systems are so well funded, it's hard to really, to build something from scratch and make a big difference. Plus, you're also competing against, Aurora and Amazon and Spanner and so forth. So I would say yes, but I think the market is sort of getting so established already now that it would be hard for a newcomer to come along and make a difference. But I'd say, again, someone could take Postgres, hack it up, and similar to what Yugabyte has done. And that would be, that would at least give them a jump start in this space.
For the last, I would say 20 years, like open source databases have really sort of taken off. MySQL, Postgres really grown, Mongo, Cassandra, different things like that. Do you think that's going to continue to be true, or will we see closed source, but maybe cloud managed, cloud native ones have other distinct advantages that open source ones didn't have, that proprietary ones before that? Like, is there an ebb and a flow to this, or do you think it's sort of open source is going to continue to grow, or what do you see there?
So the cloud makes this very difficult, right? Everyone everyone wants to be open source. Everyone likes open source. But the stuff that you end up building to run a cloud native database is not, it's the backend. A lot of it's the backend stuff, the infrastructure, and that doesn't get open sourced. Mm-hmm. Kudos for Cockroach, and I think Yugabyte as well, maintaining open source. I don't know how much is in the commercial, the service version versus the open source version. What the differentiation between the two, but at least people have that option. I I foresee Postgres continuing its dominance and replacing further MySQL as being the default choice for like new applications as the open source database. But again, I think a lot of people are going to choose to run it on RDS or whatever, pick your cloud service rather than the, trying to run a bare metal themselves. It's just not worth it. So, Postgres is getting a lot better, certainly. Put it differently, in the 2000s, MySQL was the first choice for new startups, new tech companies as the go-to database instead of using Oracle and all these other ones. Then Mongo became sort of the default choice in the early 2010s. And I think Postgres is sort of wearing that crown now. And so there'll be a lot of applications, a lot of new products being built with Postgres as the first choice. And then maybe as those things evolve and scale over time, they'll hit the limits of what single node Postgres can do, or even a slightly replicated partition version of Postgres can do. And then this is where things like Cockroach and the other services that look and smell like Postgres could come in. And so in that case, like the open source version of Postgres keeps getting better, but the cloud versions are just making it so that they scale.
Yep.
That's where I see things going.
I think that's probably right. I was just sort of struck just reading like some of the papers coming out of Amazon in the last couple of years, both the Amazon Aurora paper and then the new Amazon DynamoDB paper. And you mentioned a little bit about like the back end stuff that they're doing there. And part of that is, even in just like RDS where they're running vanilla Postgres or vanilla MySQL, there's a lot of back end stuff. But then like with Aurora specifically, how they're like, chunking your data into 10 gig segments and sort of spreading across AZs and doing all this stuff. Like, even if they did open source that, like no one, it's just such an operational burden for one team to go run that for themselves as compared to, a dedicated Amazon team that can run that for thousands of customers. I will say
there is actually an open source version of something that smells like Aurora called Neon. And this was started by the co-founder of MemSQL, or now SingleStore. I guess full disclosure, Nikita's a friend of mine. I'm an investor in them. He's an investor in Autotune. So, but they are pitching themselves to be the open source Aurora, and I'm pretty excited to see where they're going with this. And as far as I can tell, at least from what he's told me, what you get in the Neon service matches what's in the open source version.
Awesome. I love that. I'm super excited about Neon. We're trying to get Nikita on right now. So hopefully look for like an upcoming podcast with that one. So, I think there's like just this whole like serverless era too. Like, part of that's marketing, but there is some interesting stuff there about like just how much easier it's getting to actually use databases as a regular developer and things like that. And I love that part.
Again, not to go back to Autotune, but like, yes, it's super easy. But I think to me, this also is another good argument of why you want something like Autotune. If it's not Autotune, whatever, automated database automation, because it's super easy now to, with no code systems with these databases as services, whether the service or not, you can plop up something pretty quickly and get a lot of people using it, collect a lot of data. And the infrastructure is super easy for that. But like to understand how the application is using the database, what they're doing, using incorrectly, how is it even set up correctly at all, beyond the infrastructure, that's super challenging. We've had customers tell us that they thought Amazon was already tuning their database for them on RDS or Postgres MySQL. And I'm like, Jeff Bezos is not doing that, right? Like the economics is in their favor not to make your thing run faster.
Yeah.
I can't prove this, but our impression is that the default settings for our Aurora are slightly tuned a little bit better than the default settings for RDS. Like, and they want you to, so that way when you switch to RDS to Aurora, you're paying 20% more and you think it's better. But still, there's just a little bit of knob tuning will get you there.
Interesting. Yeah, that's funny. Yeah, cool. Well, Andy, I've just loved this conversation, and again, I've just loved all the talks and things that you've been putting out. So, thank you for coming on Software Engineering Daily. If people want to find out more about you, about the series, like where should they be looking for you?
So it's Otter, like the animal tune, TUNE, like play on the words autotune.com. And then you just search CMU Database Group. There's the YouTube channel for that. There's the Twitter account. And then there's the website with all the details. And everything, again, we try to make everything open source, everything public. So even if you're not a student at CMU, you can still participate in everything we're doing.
Awesome. I love it. So we'll have links to Autotune, to the database group, all that stuff in the show notes. But Andy Pavlov, thank you for coming on to Software Engineering Daily.
All right, Alex, thanks for having me. I love it.